So for every lab, safety is paramount, so you're going to want to make sure you follow standard operating procedure for this experiment. Disposing of waste, all of the waste that's going to be generated in this lab is non-halogenated organic waste, so be sure and dispose it in the proper bin over by the waste disposal. You're going to be wearing gloves for this experiment. If you ever get anything on your gloves, any solvents, any chemicals on the gloves, go ahead and take them off, throw them in the trash, get yourself a fresh new set. Using organic chemicals, glassware, heating reactions, standard operating procedure must be followed for all of those elements. The chemicals that you'll be handling in this lab, you're going to get an unknown liquid sample that contains 2 of the following 7 possible liquids: acetone, methanol, hexane, cyclohexane, heptane, toluene, and ethylbenzene. There's an MSDS sheet associated with each one of those chemicals. Make sure you know it, know the safety hazards associated with each one. For this experiment, you're going to need a 100 milliliter round bottom flask, a fractioning column, distillation head, thermometer with both the glass and the rubber adapters for the thermometer, a condenser, a vacuum adapter, 3 centrifuge tubes level A, B, and C, 3 metal clamps, 2 hose clamps, 5 Keck clamps, a 1-inch stir bar, and a 50 milliliter beaker. So, of a quick overview of the experiment, you're going to set up the entire distillation apparatus. Once that's all set up, you're going to go ahead and flag me down. I'll come over and make sure everything is set up appropriately. Once I've given you the okay, you can go ahead and take your round bottom flask, go over to get the unknown sample from the sample hood, take it back to your hood and start the distillation, monitoring the temperatures and the volumes that you're collecting. You're going to be collecting 3 fractions, A, B, and C. Once they're collected, you're going to go ahead and go and get the gas chromatograms for each fraction. You'll use the retention times to determine the identities of each of the compounds, and you'll use the peak integrations to determine the ratios of the compounds in the original sample. Sound good? All right, excellent. Get to it.